Hello, everyone. I'm Susan Nash, Director of Innovation, Emerging Science, and Technology at AAPG, and I'm really happy to be here today to welcome you to Week 8, Pivoting During the Pandemic. Today's panelists are specialists in automation, and I'm glad to welcome, first of all, David Forsberg, Ascent Energy Ventures, and also Hugh Winkler, Factor Technology. We'll be talking about automated geosteering, and Chad Hammond, DCiii, automated chemical injection controller and diagnostic monitoring. So it's very interesting today, and I'm excited because every day that goes by, we find that the importance of automation comes up in basically all aspects of our lives. So today, I think what we're really going to be talking about in great deal is cognitive robotics that are based on sensors and sensor information, but then they also use artificial intelligence, neural networks, et cetera, to not only identify patterns, but also to predict behavior. So in addition to machine learning, there's a great deal of deep learning. And I know that our panelists will be able to go into that even more profoundly. So I will stop sharing my screen and I'll give our panelists plenty of time to talk. So first of all, I'd just like to also welcome Larry Davis, Texas A&M, Texarkana. And so before we go into our first presentation, would you like to say a few words, Larry?
So I'm happy to be here. I'm thoroughly enjoying these presentations every week, expanding my mind. And of course, the 3D printing last week, I'm still fascinated by that. So I'm just leaning forward in my front row seat tonight to see what's coming forward.
That's great.
Happy to be here.
Well, as those of you who've attended before may know, Dr. Davis is a professor of economics and former dean of the business of College of Business at Texas A&M Texarkana. And the College of Business there is fairly unique because it is combined with engineering. So there's just a really unique linkage between technology and business and business decisions. So anyway, I'd like to get started. So before we start with David, I'd just like to let each one of our panelists say hello. So David, would you like to say hello?
Hi, it's a pleasure to be here. David with Ascent Energy Ventures. We're a venture fund trying to invest in companies that lead to a more digital and automated energy industry. So it's a pleasure to be here and discussing this topic.
Great. And Hugh, would you like to introduce yourself briefly?
Sure. I'm Hugh Winkler, founder and CEO of Factor Technology, and I'll be presenting a little bit about our company and our approach to geosteering.
Great. And also Chad Hammond, would you like to say hello?
Hi, I'm Chad Hammond. I have a little over 10 years in the upstream oil and gas space. I'm co-founder of DCiii Controls, a short-lived company. We've been in business about 3 or 4 years, centered around automating the production chemical injection process in operations. That's
great. So I'd just like to remind people who are maybe new or who have been here, and then let people know who are new to the series, that our primary purpose in putting together Pivoting During the Pandemic series is to basically let people know what options are out there if you're looking to diversify, and also to learn from each other and what others of us are doing in terms of adapting and adopting our technologies and new technologies to today's situations that are extremely fluid and always changing. So I'd also just like to give a quick thank you to Jalea LeMaster, who's our publicity chair, and also to Mark Hamzat, who is our I don't know how to characterize him, basically a force of nature who is on the board of UPitch, and also see a number of UPitch advisory board members in the audience. So Thank you, and I'd like to turn it over to you, David, and I'll share, I'll invite you to share the screen.
I didn't create a presentation. I was under the impression we were just talking about a number of different topics.
That's fine. Oh, that's good. That's actually better.
Okay. Is there something you'd like for me to specifically address?
Yes, exactly. Well, okay, so this is good. I'll ask you some questions. So you've started your Ascent Energy Ventures. Could you tell us a little bit about why you started it and what your goals are?
Sure. My background originally was in developing execution algorithms and systematic investment strategies in the financial markets with a famous investor named Joe Ritchie in Chicago. And we did that from about 2005 until 2013. And then I worked for a single family office related to an oil and gas family, where we kind of saw a general trend of automation and digitization that occurred in the financial industry being applied to industrial sectors, and specifically the E&P space. If you look at E&P, it has described itself and is very clearly a digital laggard for a number of positive reasons. They invested in engineering tech and other issues over the last 30 years, but they've become a severe laggard in digital adoption. So we felt that there was an opportunity for the sector to begin paying off some of that digital debt and becoming more automated and digital. So that's kind of part of our investment strategy.
Well, it's a really, really good timing because, I mean, nobody would have potentially predicted, well, I guess some people were predicting pandemic, but not many people were ready for the way that this pandemic hit. And so have you seen any changes, or are you making any changes thanks to the pandemic?
Sure. I think that startups that have revenue correlated with drilling activity obviously have slowed down, and it's difficult to raise capital for them. And the uncertainty is still high, but I think a number of the digital technology companies that offer operational type products, whether that be field ticketing or other back office type solutions, accounting, they are seeing increases in inbound calls as well as revenue uptakes. So I think that there is clear bifurcation there as the pandemic has hit for companies that allow an E&P company to do more with less. And so hopefully I think that trend will continue. And as we come out of this J curve, I think that revenues will pick up for those companies that are related to drilling activities as well. It just is going to be a little bit longer.
Absolutely. Yes. So another question that I have is, what are you seeing people feeling like the most sense of urgency? Like a couple of weeks ago, we had a talk about 3D printing. And I mean, one of the goals of many people here today is to make the supply chain more robust and to have more options, so that if a part breaks, instead of being down for 3 weeks or frantically finding where it is stuck in a port somewhere, there's the opportunity to produce it at home. Even if it's a little bit more expensive, when you factor in the downtime, it's actually a really good thing. And so I'm wondering if you're seeing, where you are sitting, any kinds of things that have to do with the supply chain.
Yeah, I mean, I think supply chain is an important characteristic that we've already cut a lot of fat from over the last 5 years, but I think there's additional opportunities there to gain efficiency. And there is some urgency there, but I think the real urgency is we just laid off half of our workforce. What are we going to do to operate the same amount of responsibilities with less workforce? And so anything that can be an urgency of reviewing processes that previously you weren't reviewing, because let's just take accounting. You had 5 accountants and now you have 1. And the question is, should we hire back the other 4, or should we implement some sort of a technology or software that can maybe allow that 1 to operate and do what the other 4 had? And I think that's where the sense of urgency is for now.
That makes a lot of sense. And another question that comes to my mind is, what are those half that got laid off going to do? And one of the things that we saw, at least in 2010, which admittedly is a lot different, but we saw a lot of innovation and also entrepreneurial spirit.
Yep.
So,
Yeah, so in
uh-huh.
2015, or at the end of 2014, beginning of 2015, we had the first recent sell-off in crude prices, and what we saw there were a number of people who had left the industry, looking around trying to figure out what to do with a specific skill set, and they realized there was a pain in the butt component to their job, and they went and started a company that helped relieve that. And so we saw a number of startups that entered the space in that vintage, and then we saw a little bit of a slowdown in that, but I think that a number of people who have been laid off in this most recent environment are going to say this was a pain in the butt, and I want to find a solution to that. And we're going to see a number of unique companies that are going to be founded over the next 2 years. So I think it's an exciting space. You know, one of the things that we forget about is that what we find difficult as a human being is often very easy for a computer to do. And this paradox is that what we find very difficult to do, it's easy for a computer to do, or what we find easy to do is very difficult for a computer to do. So if you take that and extrapolate that general sentiment to kind of the job roles, someone who swings a hammer or works in the field is much more difficult to automate than, say, a geologist or a reservoir engineer or someone who takes data and manipulates it and makes data-driven decisions, especially if pattern recognition is involved. So one thing that I think we'll see is there will be reduced headcounts either naturally or through general layoffs as well. If you Google the UBS trading floor and Google image that, you'll see a visual representation of the largest trading floor in the world and what happened after automation to a certain extent.
Absolutely. And one thing, I noticed we have a hand up, so we'll go to Munira in a second. But before we do, I wanted to ask you specifically, when someone comes to you with a project and a proposal, what are the things that you look for before you invest in it?
Yeah, I think there's a whole long list of them, and they're not particularly unique. So you can probably just Google what do venture capital or investors look for. But it's probably starts at team, product market fit, market need, those types of general pieces, and then where we dive in, and there are different stages and different investment strategies and different values that each venture firm or investor has. So I think that's the best way to just grab that list and see and check off those boxes.
So I just had a chat message saying that one of our audience members can't hear you. So I'm wondering if anybody else is having the same issue. If you can't hear David, well, he's not speaking right now. David, speak, and if you can't hear him,
I do hear him fine, Susan. I hear you great, David.
Great. Well, I'll chat on one more thing too. If you think about automation and AI, and you look at it in terms of chess, for a long time, a human being or a computer has been able to beat the best humans. But if you start looking at what beats the computers, it's a human plus the computer. And that, I think, is a ray of sunshine for what is coming to all industries, is that the best combination is oftentimes a human and the computer. So a geologist with automated decision-making and better data and a computer program that filters prospects for them and does the first 80% of the work. I think that actually is kind of a ray of sunshine for how we can do better as an industry and still employ people, because these algorithms are not necessarily going to exist on their own.
So when a person comes to you with a business proposal, I mean, clearly they're going to have at least one scenario that deals with the realities we know it today. But like, as you look at their proposal and they manage the risk and they give different scenarios, they do a SWOT analysis, et cetera, what type of things do you like to see in terms of how they envision the future?
I think everybody has a vision of the future that's slightly different, and that's what makes the future so uncertain, right? But I think it's taking what is going on today and trying to solve a problem that exists today in a unique way. And I think that's an important way of looking at this stuff.
That's good. So, for example, have you had any examples of recent proposals that really jumped out at you as being kind of unique?
Yeah, I think so much in the industry is focused on these buzzword terms, AI and machine learning, and for the most part, it's kind of nonsense. We need to start with the data gathering and the cleaning of data and the getting multiple unique data streams in to the models that then can lead to more decision making, automated decision making, data driven decision making, and then you can start doing more machine learning AI type of things. So one of the companies that I found very interesting, and I'm not going to mention their name, but they are focused very much on the getting non-digital data in the door in a digital useful format that is clean and usable, because what everybody forgets is that this data is oftentimes very dirty, inconsistent, and it's hard to do any sort of data analysis on it in any sort of scale, and then it's very hard to apply it to any other more advanced features.
Oh, that's a really good point. So you're talking about, say, old records of certain types of things or old files and just random stuff.
Even current stuff, not even old. I mean, current stuff. What is what do the words mean? In one company, WT means weight, and it maybe means something else in a different company. So being able to take all of that data and synthesize it in such a way that it is now useful, just making those little simple changes takes immense amount of effort.
That's really interesting. And it kind of makes us realize too that we tend to have in our companies or our organizations, before we realize that we've created our own language, or an idiolect, if you might say it. And we even within one division, and that communication is critical. And while you're talking about what you're doing in terms of just even making readable documents and analyzable documents, you're also facilitating problem solving by allowing people to speak the same language.
Yeah, and in that chess example, when the human plus the computer beats the computer, which beats the human, it's the human's ability to gather different data sources and synthesize that in a unique way in a complex system. That I think adds value. And in oil and gas, that means breaking down information silos between the different divisions, so that way everybody can understand what's really going on, and it's going to be the synthesization of these unique data feeds that will unlock unexpected value down the road.
That's really interesting. It's a really good point. So one of the things that Dr. Davis does, that Larry does, is he teaches strategic planning. So are any of these, anything come to mind, Larry, as you're listening to David? You're muted.
Helps to unmute. Yeah, there's a certain model that I use in the strategic planning process, and the significant thing is to do an evaluation of environmental factors that can change and can affect a company, and that's what's been being discussed here. And in previous weeks, you know, the environment has changed so much in the last few months, and in the planning process, it has to be more dynamic and flexible, and have tune-ups to it along the way, rather than just, you know, setting it in concrete and moving forward and having a disaster. One of my thoughts as David was talking, I've made observation, a lot of people who have worked in offices are now working from home, and the technology that they're using has seemed to have been enhanced in some instances, and they become more skillful with the technology that they have to use. And in a lot of ways, it seems that some of them become much more effective employees in the way they're dealing with their company responsibilities now.
Yeah, I mean, I think that's very true. I mean, think about suddenly people are going to have to start using productivity tools such as I don't know, Slack, Microsoft Teams, those types of products, CRM softwares that exist and are widely used in other industries, but are not as widely used in this industry. So remote working is starting to break down those barriers to adoption. And as this tornado has come through and kind of leveled the landscape, new buildings and new ways and processes will be built upon this opportunity.
Really good point.
It seems too that some companies are mistrusting of their employees and working at home. They're afraid maybe they won't get up and get to work on time, or be committed to the job responsibilities. But it's turning out that that's really not a valid concern in most instances. Some of the employees seem to be even more productive in their own environments.
Yeah, I think that's a true statement, and a number are. I'm personally not. I'd much prefer to be in the office, but I know that is the case, and I have a number of friends that work in the chemicals and E&P space, and they have now all the barrier to being able to work from home or work remotely or work in a different location than say Dallas or Houston. Those barriers are now knocked down, and a number of them now live in one moved up to a lake in Michigan, and one moved to Denver. So, and that's already starting to happen. And these are permanent shifts.
Well, I was noticing that there was a big surge in real estate sales in the Catskills, north of New York City, for kind of obvious reasons. And again, like you're saying, that's permanent. People are saying, well, I don't have to. I used to live in upstate New York, and there were people who would take the train like once a week down to the city and then work remotely the rest of the time.
Yeah, the Wall Street Journal had an article recently that was titled, "I can work from anywhere. Why do I live here?"
Exactly. That's really interesting. Well,
another observation, where people have offices and they have to buy equipment, furniture, telephones, office chairs, the desk. As they transition to allow people to work from home and that becomes effective, the expenses of a office would be diminished considerably. You don't have to buy the desk.
And think of it from an venture perspective. I read a stat that wasn't well backed up, but let's just assume it's true, is that in Silicon Valley, 40% of venture capital money goes to real estate. And it's just, if you think about it, that makes some sense at some levels. And so the landscape for office work and is drastically changing, and technologies are going to come in to enable that kind of change and scale.
Absolutely. So a great opportunity to figure out how to repurpose office commercial real estate offices.
Well, Susan, you're a good example. I mean, knowing you there's no telling where you might be working tomorrow. I mean, you worked in Denver, you may be in Tulsa, you may be in Oklahoma, you may be in Houston, you may be in China.
Well, that was really good old days, being able to travel. I'm like many of us. I've been this find a connection. I can be in Africa or wherever, and it's fine.
But the point is, you made it work.
Yeah.
If you're away from the office, you didn't get the opportunity to shut down for the day or for the week.
Well, I would think that probably the majority of people in the audience have actually had that experience, and it's great, and it's also kind of a lot of pressure because you never have any downtime. And so I think that's one thing that I might talk to you about. Also, David, what do you do about the downtime?
The downtime?
I mean, that like there is none.
Yeah, I think one of the advantages of all of this too is that programming talent is difficult to recruit, and I think from a recruitment of talent perspective, if E&P is it's hard for E&P to compete against finance and Silicon Valley and other things, and now E&P can probably grab some of this talent because if they're more flexible, you can say live in Denver. Live wherever you want, as long as you're getting your work done, and we have productivity tools to measure that. I think that there's a golden age of automation and advancement here in the E&P space.
Absolutely, and creative envisioning. Well, that's great, and we'll have some time at the end for people in the audience to ask questions and exchange ideas. But want to thank you, David, and let's move to Hugh Winkler, who is going to talk to us about geosteering and application of automation. And Hugh, you're muted.
Thank you. 1 second. You know, Susan, it's not really, I'm pressing the share screen. Here we go. Never mind.
Okay, good.
How's that? Is everybody seeing our title slide?
Yes.
Looks good.
Thank you. I spent a lot of time on that slide. I'm Hugh Winkler. Thanks everybody for attending today. I'm going to introduce you to our company, Factor Technology, and our product, Factor Drive, which is the first technology to fully automate geosteering. This is a little video, and I hope it doesn't, hope that it transmits pretty well over my low bandwidth connection here in far western Travis County. This is what our program does. And so some of you will be mystified by what you're looking at, and others will be more familiar. This is most of what you're seeing there is a conventional geosteering display. And the blue line that's traversing left to right across your page is our computation while you're drilling a lateral, speeded up about 100 times, of the geologic surface that of the top of the zone that you're drilling through. And that's an important manually done job right now in horizontal drilling, with a geologist doing that same job manually. We do it automatically. And if you're at all familiar with a typical geosteering interpretation workstation, about 80% of the screen looks familiar to you. And then there's this weird looking river of flame going through the middle. So I'll describe what we're looking at here. The upper blue line is our computed most probable structure, given the while drilling gamma ray measurements and the directional surveys. And a pretty conventional display on the left of the type log. That's a vertical gamma ray log that the geologist thinks represents the geology in this region, the stratigraphy, I should say. And superimposed on that in color are some projected while drilling gamma rays. And when these projections line up well on top of the black lines, then we call that a good correlation, and it gives you a little confidence in your interpretation. And it's the same for this other display. We call that the predicted LWD, and really all you have to know about that is that when the colored line overlies the black line, pretty much you can have reasonable confidence that you're getting a plausible answer. The new thing that we introduce on top of just computing this answer, but something, a side effect of our computation is that we're able to tell you the confidence you can have in our answer. So the blue line is the most probable structure. This probability field kind of gives you a feel for how unique that blue line really is. And in this particular case, I chose this one because we're actually seeing in a case where there's an alternate interpretation that a geologist for some reason might prefer. We've chosen the single most probable one as the blue line, but when there's ambiguities, we can present information to a geologist that he can use to make the best decision. We were founded about 2.5 years ago to commercialize this technology. We went right away to a couple of startup competitions, and we won a couple of prizes. And we've spent the last 2 years productizing and commercializing this technology. in cooperation with a couple of oil companies. So let me tell you what motivated all this work. In the old days, which is before 2010, geosteering was an art that geologists did. They had 3 or 4 hours between directional surveys, and they would get new surveys in and they would load them into interpretation desktop software and update a geologic model, and if necessary they would update a well plan and send that off to the directional driller. And that worked pretty well up until the mid 2010s or the early 2010s. And then, especially after 2014, drilling speeds got dramatically faster. From 2013 to 2017, it's safe to say that they at least tripled, and in many cases quadrupled, and 400 feet an hour is no longer a very out there case. And what that's done is given geologists far less time to do this work. In fact, they physically cannot keep up and do an interpretation with the fidelity and care that they used to do. And it's necessary, if you're going to use geology to guide the well position, you're going to have to do it with a computer. So that's what we've done. We've come up with the algorithm. 3 years ago, I published this paper in Geophysics describing a complete, rigorous solution to the geosteering problem. And I think I shouldn't have to point this out, but before you can automate anything, you better be automating it with a rigorously correct, defensible solution. And so I think we can safely say we're doing that. It takes a really large computation. So something else that fortuitously has happened in the last decade is these general purpose GPU computations have been commodified, and you can even rent them by the minute in the cloud. And that's what we do. And it suits our business model very well because we can stand these things up at Amazon for about 10 minutes, do a computation, stand them down, and pay about 75 cents. They're massively parallel computers with lots of RAM. And we deliver the results and the interactivity to the customer through a web interface. So the web user interface plus cloud compute is sort of our architecture. So just to introduce you to what problem we're solving, you're given that type log, which is usually a gamma ray log from a vertical nearby hole. And then you're also, the geologist knows he has a lot of good idea of the regional geology. He has seismic data, he has neighboring well log interpretations, and he generally has a good idea of the geologic structure in general in this region. And he knows the faulting regime. And then we're going to assume that the geologic structure varies mostly by dipping and faulting. And then as you drill the lateral, you're going to be acquiring these measurements, and you're going to combine them with all that other prior knowledge, and you're going to infer the true geologic structure. And that's a real Bayesian formulation for those of you who know about the Bayesian approach. So geosteering is a really hard problem, and you do a literature search and you don't find a comprehensive solution until, as far as I could tell, my paper. And the reasons for this, it's not an analytic problem. So first of all, there's many answers. It's a very non-unique, the same well log while drilling could represent many different answers, and you have to discriminate amongst them all. So you can't just use some off-the-shelf method to find the one that best fits your data. And I think a byword you could say, anybody could safely say in the business is you can safely say that if you've made a good interpretation, you'll see a good correlation on your to your type log. But the best correlation doesn't mean that you have the best interpretation. And the second thing that makes it a hard problem is that it's a global problem. So you can't just do local solutions, get some data at 5,000 feet, get some gamma ray, get some directional surveys, and then solve the problem there. The new data you acquire at the toe of the well can influence your idea of what happened all the way back up the lateral. So you could get to the 5,000 feet and get a new gamma ray reading in that says you've been in the lower bench instead of the upper bench all along, and that has to change your interpretation all the way back up the lateral. So any good computation software to solve this problem has to address that. And finally, if you're going to discretize the problem and model geology, you've got an infinite possible number of combinations to model, and it makes it a really hard problem. There's no analytic solution to this problem. There's only a probabilistic approach. So what we call an answer is not an answer necessarily, although we can give you the most probable answer, but there may be multiple answers, and the answer is the totality of all those. So we model everything as discrete random variables, and you can think at each position, we chop the lateral up into thousands of positions, and in each position we have a dozen or so random variables. And each of those random variables, and those things are like gamma ray reading, the inclination reading. The inclination reading is, you know, a certain inclination, but there's some uncertainty about it. And many other random variables at thousands of points along the wellbore. And conceptually, what you're doing is you're going to multiply all these little probabilities together and search that big multiplied together space to find the configuration that has the highest probability. But that naive way I just described it is really impossible to do in any real case, because there's an impossible number of configurations. Well, that's why we brought in the Bayesian network. So this is a concept that was developed in the mid-'80s, and it's survived the AI winter, and it's been successfully used and had a resurgence in the last decade in robotics and in autonomous vehicles, and it's got a lot of miles on it, and it's well studied. And it's got properties that allow us to collapse that huge problem into a tractable one that we can fit in a large but a commodity off-the-shelf computer. And the answers that it gives you are exact probability numbers. We're not minimizing a least squares problem. We're not Monte Carlo searching a large parameter space. And I want to emphasize, this isn't a neural net with a black box that we don't understand how it's working. We've built a real physical model. We've modeled this physical model of geosteering in the Bayesian network, and we totally understand how it works and its limitations. And then just to convince you that we can get some really good answers, here's an answer where we've compared oil company geologist interpretation in purple there to our geologic structure, the blue area. You can see they're very similar to what the oil company geologist found. And the convincer is that we've got these really great correlations between the colored well log tracks, well log curves, and the black ones. I just want to mention something that we think is a great opportunity for us, and that's directional drilling advice. So what I've showed you so far is is telling a geologist what the current situation is, and he makes the decisions. But in the future, we want to leverage this knowledge that we have of all the probabilities, and we can help the engineer make the best bet for adapting his, for changing his well plan or changing his drilling direction and getting back to the plan. And to do that, you penalize tortuosity because you can't bend pipe too sharply, or else you'll have well problems. But you want the most possible exposure to hydrocarbon. And anyway, we think this exposes us to a much larger market than the geosteering market, and it's a great opportunity we plan to work on in the next year. I think that 10 years from now, nobody will be doing manual interpretations. Everybody's going to be doing some form of automated interpretation, and we can see competitors out there forming already. We think we're ahead of the pack, and we have a chance to maybe lead the pack and be there 10 years from now. That's about it.
Hey, Hugh, if you're using Bayesian updates for your machine learning, what's your prior, and is it previous wells, or is it previous data as you steer?
It's generally it's previous wells. So when you're that vertical track on the left with a gamma ray well log on it, that's from a offset well. It's not the well you're drilling now. But it's representative of the stratigraphy you're going through. So that's your starting point for what the stratigraphy looks like. And then horizontally, the geologist, he might not know much. He might just know some regional dip and stripe, but generally they have a map, and it needs updating. It's not a perfect map, but it's a starting point, and that's our prior.
That's really interesting. So why don't we go to our next speaker, and then we'll hold questions. I know there's some questions in the audience. Let me check to see where we are with questions. If we have some that absolutely, okay, everything's been answered. Okay, that's good. So we'll everybody start thinking of more questions, and we'll have them at the end. And anyway, Hugh, I just wanted to thank you. And my personal feeling is that this will be good, not just for geosteering for oil and gas, but for any type of laterals, essentially.
Do you mean outside of the oil and gas industry? Or?
Yes, I'm thinking of like coal bed.
Oh yeah, well, I'm talking to a guy right now about a coal bed methane project, as a matter of fact.
I mean, it's oil and gas, but it's also, I mean, it can be used for mapping and mining as well, so.
I think there's a point I'd like to make because it touches on what Andrew had mentioned about this period where in his scenario, they used to have 5 accountants and now there's 1. Well, in our world, there used to be 5 geologists and now there's 1. Mm-hmm. And we're going through a time right now where it doesn't look like there's going to be a resurgence real soon, but it's a slow time during which companies can get acclimated to a new technology. And it's kind of hard to get their attention during the boom times. And sometimes the time they can adopt new technologies is during this sort of retrenching period. And a technology like this, or the technologies that Andrew was talking about, that David was talking about, allows you, this gives you time it allows you to scale up as you increase your employees later when activity ramps up. So I think this is a good learning time, and it's not a bad time for our company right now.
Absolutely. Great. Well, thank you, Hugh, and want to express our appreciation. And let's move to Chad Hammond. So if you can great.
Let me try to share my screen. Can everyone see and hear right now?
Perfect. Yeah.
Great. Now I'm going to try to go into starting the slideshow. What we've learned with Zoom is that with two monitors. Every now and then when I press present, you see the presenter view, not the actual slide. I hope I've got that figured out to start this. How about now? Can you see the actual slideshow or no?
Well, we see teeny tiny little index slides on the side, but this is good.
Okay, so I'll go off of this.
Yeah.
Yeah, thank you everybody for joining, and thank you so much, Susan, for hosting this. Really appreciate the time, and hopefully we can kind of bring some real life examples and things that we've seen and experienced over the last few years to add to the discussion. You know, actually very, very fitting, you know, the title of the, you know, of the series. One thing that we were talking about today is we've actually seen quite a bit of increase in interest during the pandemic. Hopefully not just because people are stuck at home and have nothing better to do than listen to us try to give them sales pitches. But I'll kind of go into why we think that is. And a little bit of background on us is we actually started the company at the start of the last downturn, the downturn we feel like we never got out of. We started to brainstorm in 2016 on this solution, actually by request of a lot of E&P customers that we had through some legacy businesses. We had people coming to us asking for solutions to automate and digitize the chemical injection process because they were getting requests from senior management on how to reduce one of the highest operating expenses. So through that downturn, we developed the product, we developed the solution. We have about 5 anchor customers that have adopted this throughout their organizations that we've seen them experience great benefit with. However, but prior to the pandemic, we had actually narrowed into really just focusing on mid to large size operators on the purpose of saving chemical costs for rapid declining new wells. That was kind of the lowest hanging fruit, biggest bang for buck, and that was what we were seeing a lot of traction with. Well, as we know, in the last 4 months, that has completely changed, and we're actually starting to get increased interest from smaller operators that are just trying to reduce general LOE. And then finally in this process, we're getting true buy-in from the chemical vendors themselves. And I'll kind of go into that, our thought or reasoning behind that here on this slide. If you look at the way the chemical production, chemical business has been run, it's been run the same way for about 40 years. It's very labor intensive. It's very much built off of trust. Sometimes trust not even verify, trust and kind of verify. And then typically when there's a downturn, like we've all experienced on the service provider side, you know, the operators, producers come and negotiate you down, and you hope that it's a short-lived pain, you live through it and then bounce back. Well, unfortunately, I think, you know, it's almost every day you pick up the Houston Chronicle or see an article on LinkedIn, the pain and bloodletting on the, you know, on the service provider side was never really lifted from the 15-16 downturn. So now with the pandemic coming into play, especially on the chemical side, there's really nowhere to turn. The typical methods of reducing cost for chemical, you know, price reductions, maybe producers bring in additional competition, managed competition to drive price down. They try to eliminate manpower. Some of them foolishly will actually eliminate production chemicals, which we all know is not good for the long-term health of their field and assets. So really, other than chemical companies operating at a loss, there's not much more relief that can be given here. So right now, both the operators and the suppliers are being forced a little bit, being made uncomfortable to think outside the box. And kind of lucky for us, a lot of them are starting to dive a little bit deeper in the waters of adopting automation for administering chemical programs. I took this from David and actually put it in the slide when he was talking, you know, kind of like he saw industry being a lagger of digital adoption. If we think the oil and gas industry as a whole is a lagger of digital adoption, the production chemical space in the oil and gas industry is farther behind. You know, I'll always reference to people that this modern wave of digital adoption in oil and gas feels like we're moving from 2000, the year 2000, 2005, up to 2020, you know, after the big tech boom of 2010 to now. On the chemical side, we're still in like 1980. We didn't even get the 1980 to 2005 automation revolution that happened in oil and gas. So there's definitely a long way to go. But on the flip side of that, there's also a lot of people very set in their ways. It's a part of the industry that's operated the same way for many years. So really kind of like what's happened in this downturn during the pandemic is kind of forced those people out of their comfort zone. And like I said on the previous slide, we've seen a great, tremendous increase in interest. Doesn't mean the people that have interest have any money right now to buy the solutions, but there's definitely a large increase in interest. General issues, and I talked about, of course, general cost management of the business side being a big issue. Other industry issues with production chemical programs come down to the fact that operators are starting to feel pretty uneasy with the lack of transparency. Some programs today, chemical vendors just provide the operator with a bill at the end of each month, and pretty much have a trust and sort of verify type relationship. So operators, as they move and progress in this digital world, are starting to realize that they need digital tools and automated tools to help them eliminate some of that distrust and bring transparency into this part of the business. There's also a lot of issues with pumping variances. The equipment in the field today is not very sophisticated. So although a chemical provider or an operator might think that they're administering a set amount of chemical, when you do actually go out there and try to, and the individuals at either company try to verify it, there's a lot of variances, sometimes upwards of 20 and 30% of what they think or has been recommended that they administer in their chemical program and what is actually being delivered. Automation, again, is the answer to that. It is a very labor-intensive program to run. Any point in time, 40% of the individuals driving a onshore lease in North America might actually be related to chemicals. It opens up a huge can of liability, both for the operators and the chemical companies. And then, of course, in the Western world in oil fields, even during downturns, manpower is quite expensive. The burdened wages of manpower are quite large. Just a field technician for a chemical company, burdened wage after a truck can be upwards of $170,000. And that individual might only be able to cover 100, 200 type injection points. So that's a cost that either the chemical companies are hit with or they pass along to the producers. I did talk a little bit about general equipment reliability, but the chemical pumps that are in the field now, and we're talking hundreds and thousands of them around the world, are they're rough, rugged oil field application, call them kind of dummy pumps that aren't the most reliable pieces of equipment. So if you're able to find a way to, at a low cost, automate or digitize or digitally monitor and control these, you don't have to go in and retrofit or actually swap out these hundreds of thousands of call them kind of dummy or unreliable pieces of equipment that are existing in the field today. So our solution, we basically took a 10,000-foot view of the industry today, the labor-intensive part of the industry. Basically what happens is chemical companies have field technicians that drive around a lease to hundreds of different chemical injection spots. The gentleman, or lady, if they're doing their job properly and actually get out of the truck, will get out of the truck. They do a calibration method, drawing down the pump, charting what they believe the pump is performing, and then they adjust the pump on kind of a dummy timer to reflect what they wish to achieve. Current practices, that's done about once every 3 weeks. What we've automated is it's done once every 10 minutes. So where current companies might get a calibration and check, physical health check on these pumps once every 2 to 4 weeks, we're doing it every 10 minutes and reporting back in real time the condition of the pump. At the same time, we have control over the pump. So by knowing what the exact operating conditions are of the pump at any given point in time, and knowing what either the chemical company or the operator wishes to dose the chemical, whether it be a cascade flow based off of production rate or even just a set quantity, we turn around and then tell the pump exactly what we want it to do. And we're able to verify that the pump is actually following through with what we're telling it to do, because we're sitting there both controlling and monitoring the pump. There are a few solutions out there in industry today that do not do that full process. They actually do not have a physical replacement of what the human steps are. So by quote unquote, in their terms, automating this system, you're usually only accomplishing 20 or 30% of the overall process as is performed today. And then in turn, you get 20 or 30% of the amount of data available to make real-time decisions and fully automate your system. So a few things, I know I've talked about this a little bit. One thing I just wanted to highlight quickly here is that another thing I kind of stole from David and the other conversations as we were talking is the automation plus human step. So by us automating a very labor-intensive process that takes up thousands of hours for producers and chemical companies alike, we basically give both of those people the opportunity to either eliminate that manpower off of their G&A or utilize these resources in parallel with the automation and the data achieved from the automation to do more important tasks. So by eliminating the thousands of hours spent doing these very rudimentary tasks and checking on the pumps and adjusting the injection rates, we can free up chemical technicians to maybe in a given day, managed by exception off of a daily report, go check on 3 injection points, and then come back and work with production engineers really on tweaking production chemistry, dosing rates, things that can actually add to true step changes in the industry and bring an additional level of value in the collaboration between chemical companies and producers. We created the application basically to be fit for purpose in the oil field. It had to be a very simple retrofit that would exist on any tank and pump in the field. We didn't want it to be intrusive into a tank or system just due to sometimes there's different barriers of ownership in the chemical equipment. And then an important part that we've seen, and I'm sure it'll come up as a topic of question, is we really wanted to give everybody the opportunity to be communications agnostic. We're not trying to force people into the cloud. We're not trying to force people to a specific dashboard. We want to create, and call this maybe like an edge device, create useful, immediate data that can be brought in and used immediately by the end user in whichever format they wish. So I kind of view our solution as we are the gateway to accessing useful, easily available data. And then we go side by side with you to help figure out the best way, not only to get that data into whichever system you wish to utilize it for, but also the lowest cost option as well. We have a pretty lengthy list of kind of a win-win for both operators and chemical companies. And I know we've talked about it before, so I can pass this along to Susan to share with anybody in a PDF. But really the point that we drive is the win-win is we give you the capability, the data and the capabilities to eliminate unnecessary manpower and show you real-time pump rates, the amounts injected, system statuses, battery voltage, and we create custom alarms and parameters to where both chemical companies and operators can truly manage their programs by exception. We mentioned earlier some instant payback opportunities, and I'll kind of talk a little bit here about what I call sort of the Rolls Royce of automation when it comes to chemical programs. This is something that 3 of our customers now, I think between the 3 of them in the field, they have about 700 units actually operating on this cascade flow or autopilot type function. What we can do and what we actually try to do most of the time is either directly into our edge device or somewhere within, whether it be the cloud or the operator's SCADA system, we access production data, and then we're able to basically cascade flow dose off of parts per million quantity of chemical that's determined by the chemical company and the producer, or off of just a straight quarts per barrel production level, and actually vary that production flow. So I mentioned earlier, prior to the latest downturn that we're in, the biggest bang for buck were the rapid decline wells and the shale plays, and a lot of people would actually be able to put this automation device on the well AFE. And for a small automation device on a well AFE was basically an equivalent of a rounding error. So a lot of people would try to build this in to their upfront new well programs and really eliminate, a significant amount of chemical trying to track and trace that rapid decline of that well in the first 6 to 12 months. We've had examples where the customer has saved over $10,000 in a matter of 2 days. So we go from talking to people on a good day about an ROI of 3 to 4 months to, in some cases, an ROI of a matter of days or weeks. Here's just an example of some of the reports that we can generate, both to operators and chemical companies. What a lot of our customers use this for is the managers get a daily report in the morning, look it over, they might see some alarms and errors, and they dispatch employees as needed to deal with that, and then basically have them come back to the office to focus on more important things. And then finally, just some pictures of some installs in the field. This is our smart low power circuitry controller that piggybacks off of the existing solar or battery system that's operating the pump. And then our small, lightweight, easy retrofit, we call it kind of the plumbing part of the device. So kind of in line with the ultimate goals of automating the oil field, had to make it simple, lightweight, intuitive, and really foolproof for anything that might happen in the field. I know I ran through a lot pretty quickly, so if anybody has any questions, we're happy to field them when we kind of get into the Q&A part of the program, but thank you, everybody.
Well, thank you, Chad. That was really interesting. And it is fascinating to see that just a massive step change that happens when different industries have been able to get away with being a laggard and avoid investing and that eventually catches up with them. So we have some questions from the audience, and we'll see what. Okay, so the one seems to be kind of personal, but Hani says very interesting presentation, Hugh. I agree regarding potential of DD. I would like to talk more about that at some point.
Thank you.
And for David, what do you think of the delivery of the future of delivery drones and robot services for other sectors?
I think it sounds fun. But I think there are a number of hurdles, noise, regulatory issues that I think will delay adoption for the foreseeable future.
And I think with robots sound great. They can be expensive and easily broken. So that I think you have to really plan out where the robot is used. interesting. So any questions from the audience? I know Alan Bertin had an interesting question and comment. Alan, would you like to speak?
Oh, sure. And you hear me okay, Susan?
Yeah.
Sure. No, I mean, and first of all, we should say that, we all bring our own kind of personal experience to discussions like these. And I come from the interpretation side. I like to say, I only do one thing. I put a cross on a map where I think the oil is. And, that's a very complex, multidisciplinary problem. I think, Hugh, you alluded to that. So the subsurface is incredibly complex. Every data type is highly imperfect. And that, to me, is the challenge. You can have the greatest algorithm.
Oh, I'm sorry. Oops. Ah.
Sorry, am I still on?
Yes, that was me. I promoted you to panelist and somehow I disabled you. So,
Yeah, okay.
microphone.
But anyways,
Sorry.
so I think those of us who work with Mother Nature day in, day out realize how imperfect it is. It can be anything as simple as, typos in formation tops, as was alluded to. Think of biostratigraphy in the Gulf of Mexico when you try and correlate wells. One person's text W is somebody else's whatever, big hum, et cetera, et cetera. So believe me, I believe in anything that saves my time. I'm fully workstation proficient. I happen to use Kingdom, but I do everything myself. Don't trust anybody to load my data other than myself. But I always think it's a balancing act. So we want tools, but you don't want to go so far that you let the tools do too much for you, because that, I think, could lead one in the wrong direction. And I think, David, your answer was fine, so I think we're kind of on the same page.
Yeah, I think we agree more than we disagree.
Yeah.
Well, that's interesting. So any other questions? Anybody have any?
I've got one kind of for David. One thing about the just kind of what we've seen, a bit of a disconnect from the startup and venture capital side to sometimes what the operators are looking for, are looking to develop in automation or digital technology. I know a big buzzword or a big desire for a lot of startups is kind of the Silicon Valley or Netflix model of sign up as many recurring revenue type customers for a digital product or service. And typically what we've seen in the oil and gas space is that depending on the type of solution, the producers, or at least the larger ones, are typically less willing to sign up for subscription type services as opposed to buying, owning, and implementing their own type of automation solution. Is that something that you've seen, and kind of how do you pivot or look at business models when they're focused one way or the other?
Yeah, so different business models are going to have different, or different businesses are going to have different business models. The SaaS model, which is what I think you're referring to, is not necessarily ideal for everybody. It is ideal for certain companies, but the reason is that model exists is that Microsoft, instead of paying $500 to get Microsoft Office, you pay $50 a month. And so rather than, and then where that cost goes on the balance sheet and the income statement is part of the advantages of a SaaS business model. But yes, I don't know that it necessarily applies to every model. Like in your case, there is a new hardware as a service type model that people are renting or leasing the hardware from you at the well site. So it just depends on how you're financed and structured.
Hey, David, this is Hugh. Something you said when you were speaking about, this seems to have gotten a lot of attention, was when you talked about WT, some people using different abbreviations and different symbols for different quantities. And, 20 years ago, there was an incredibly hyped technology around semantic web and ontologies, and there was this, I guess the hypers were pitching that it was going to resolve all the business to business, the babble of different languages being spoken. And then it sort of fizzled out, and probably it doesn't work. And I just wondered, though, it's still a perpetual problem. I had a few years service at Drilling Info, and that's a big problem for Drilling Info, is cleansing data. And so what's your perspective on, is there any sort of lurking tools out there, this magic bullet that's going to help people clean their data?
So cleaning the data, there's no magic tool. There are algorithms that can be run that you can, depending on what data you have, and it can highlight it or bring it to the attention of an individual. But cleaning data is a labor-intensive component. I thought that there was another component too, which was, to your question, which was communication. And so those are improving drastically through individually written APIs. In finance, they actually came to a unified, which is easier to do in finance, but a fixed protocol, which is just a unified way and standardization of how to communicate between entities. I think we'll start seeing more APIs or someone who creates an API layer that ties into the drilling infos, the IHSs, all the data providers, and you just write to that API as an E&P company. So kind of like a Comcast cable, if you will, where you get all these different channels and you subscribe to the channels, but Comcast has brought them together. But yeah, data cleaning is going to be tough.
So I noticed that Sunil Garg is in the audience. I don't know if he'd like to speak about data cleaning. I know that's one thing that he does.
Yeah, Susan, I was actually typing a comment there in the box.
I'm going to make you a co-host so you can see, so your camera can open up.
Sure. Let me know. Okay, now I think.
Yes, perfect.
Okay, so Hugh, just to comment both, and especially also what David said.
That's weird.
Okay, so I will say again. So I said there is no magic bullet to cleaning. And in fact, I have a webinar tomorrow, which kind of shows similar things as what Hugh showed just now. So part of that is, in fact, data cleaning. So we use a combination of domain rules and machine learning techniques to clean the data. It's neither pure machine learning, right? It actually started with domain rules, but slowly what we capitalized on was we realized that the amount of data was so large that traditionally what we have done with the domain rules is never going to scale to that. So we intelligently combined the statistical techniques with domain rules in order to clean the data set. And this was done primarily for, in fact, the formation tops prediction problem. So that's my webinar tomorrow, showing the entire workflow from data ingestion to data cleaning to machine learning model, and then effectively, of course, what you were showing, Hugh, which is deploying that in a real-time drilling scenario. And in the past, in fact, I used to develop a rules-based cleaning engine at Schlumberger. Okay, so that used to be one of the products in my portfolio, was a rules-based, and a lot of these rules were really domain-specific rule, or some of them were simple data check rules, right? But lots of them were basically, centered around the validity of the data kind of rules. And like I said, right, with the volume of the data that is there right now, lots of those techniques, they work, but they just can't scale out. And that's where we essentially use the power of data analytics to scale those techniques out.
That's interesting.
If you have time tomorrow, maybe, so our webinar is at 8 a.m.
Is that with the energy and data?
Yep.
Perfect.
That's the energy and data webinar tomorrow, right? So
excellent. So everyone, there's an energy and data webinar. It's a co-production of AAPG, SEG, and SPE. So the webinars are excellent. And Sunil's presentations are always really good. So any other questions? or comments? Alec, I noticed, I don't know if you're available to Alec Walker also does a lot of analytics. It'll be interesting. So I have a question for you, Chad. So as we look at some of the equipment, and then you go back into some old fields, you mentioned looking at shale wells that were in the early stage of a high rate of decline, and so trying to like maybe take the edge up, like at least ameliorate that situation. But do you ever go back into old wells?
We do quite a bit, and actually we go back in for a range of reasons. Sometimes it's even just to control an extremely low rate of injection. Sometimes over injecting can actually be harmful, and current equipment on the market usually can't dose below 4 quarts a day, and we can dose as little as half a quart. So we've actually been brought into legacy wells for those reasons, and then also just especially for very geographically sparse fields, just to minimize the amount of effort and time spent traveling from one location to the other.
Mm-hmm. That's interesting. So
I guess, Susan, if there's no one else has any questions, I might talk about wells again.
Good, yeah.
And, I'm going to say, again, back to AI and ML and so on. And, I always like to say we hear a lot about the seismic side of things. And actually, the seismic is the easy part of our business because, yeah, it's terabytes of data, but it's relatively well behaved. SegWi file comes in, you can massage it, you can apply all your artificial intelligence. The real tough part is the well data and, things like those tops. I don't envy what Drilling Info and IHS and others have to do because do you know how many wells around the Gulf Coast have the 10,000-foot sand and have nothing to do with each other in any way whatsoever? So that's the trouble. The wells, they may not even be in the right place. Surface location may not be in the right place. You may not have the correct bottom hole location. Perfs may not have been measured correctly. And the list goes on and on. So I always like to say the seismic is the easy part of the business. And I'm a geophysicist, so I guess I get to do the easy stuff, so to speak. But no, the wells are the killers. And the wells ultimately will cause the dry holes. And if you don't put the effort in the dry hole or in the wells, doesn't matter how much AI you put on the seismic and this attribute sweetness, everybody loves sweetness. I'm not sure why, but anyway. It won't fix your bad tops. It will not fix your incorrect tops, which go into the databases. So no matter how smart the algorithms are, if your biostratigraphers aren't on the same page, it ain't going to work. So anyway, sorry, but I always like to say the wells are the tough part in this business.
That's really interesting. I think that's a really good point. I noticed that Joel Alberts is in the audience and he had mentioned a few things. Joel, would you like to comment? I think you're muted. Or maybe he doesn't want to. Okay, Joel, sorry. So any other thoughts about these issues?
So, Alan, quick question for you. Your argument is not that your argument is that the data is bad, but if the data was good, you could do a lot of different things.
Absolutely. I'm a great believer in the algorithms and so on. I just don't believe the data that goes in, and that comes from having spent times in Pemex's filing cabinets in Mexico and seeing where they have their tops next to the where they keep the chickens. And I'm kind of joking a little bit, but the data, that's the challenge. And like I say, biostratigraphy alone, this is people looking down at a microscope in a dark room and, they look at the shapes of a fraction of a little fossil and one person tells you this is fossil ABC. And on that basis, they establish a stratigraphy. Another biostratigrapher in another company sees a slightly different fragment, calls it differently. You can't just take those tops. And by the way, if you want them, just go to the BOEM You get thousands and thousands of tops provided by operators for the last 50 years. You're going to see they just do not match easily. Maybe Sunil's figured out how to make them work, but never underestimate how bad your geologic, your well data is what I would say. Even not that the seismic is perfect either. You got multiples and many other things, but this is a big challenge, and anybody that thinks that we just apply some quick learning, I just think is overly simplifying it.
I couldn't agree more. I mean, that's why my argument is it's data gathering, data processing, leading to development of data-driven models, and then data-driven decision-making. And then we're finally at automation. And then you can start doing weak forms of machine learning. And from there, maybe some, what certain people are calling AI.
Well, that's a really good point. And in terms of, Sunil pointed out that a lot of publicly available data is just frankly bad or doesn't correlate. And so anyway, if anybody wants some of that publicly available bad data, I've just put together what's called the Geological Toolkit, and it will be available at, on AAPG's website. Put together the prototype, but they're making it look nice on the web team. But it has links to where you can get free data. Now, again, you know, you get what you pay for. So free is not necessarily accurate, and it definitely needs to be cleaned. But there's that plus reports. And I think it's quite interesting to see how many major plays and acreage blocks were purchased based on USGS reports. One that comes to mind right now is like the Scoop and the Stack. If you look at the USGS reports that are talking about migration pathways from the deep Anadarko all the way up to Kansas, it's like every place where they said there were going to be the pathways and the preferential enrichment, boom, it became a Scoop and the Stack. And it's like I remember Continental called it their stealth play. But I mean, only stealthy because they were purchasing acreage, not stealthy because of the report, which is totally open.
So Susan, since you mentioned free data, I'll make some quick comments on that too. So yeah, I'm aware of all the free data types, BOEM, and you know, so again, anybody send me an email, I'll show you how to get free data in the Gulf of Mexico, and you can do it in Louisiana, etc. And you know, the whole argument of Drilling Info and IHS and companies like the OWL database is pay us the money because we clean it up, and it's tremendous value. You're far better off paying us $20,000 a year, for example, if that's the OWL database. And I cannot agree with them more. So I'll be the first one saying, go get the subscription. But even there's still a lot of remaining problems after all the cleanup they've done. And so it's not just a simple thing, is all I'm saying. It's kind of an endless thing in some ways. Again, I want the shortcuts. I want the AI. I think as long as you know your data well, you know it very much in detail, you know the limitations, then you can go to the AI. You know, you don't have to have perfect data, but you got to understand your data and its weaknesses.
That's a good point. One of the most nightmarish places I've ever worked was Granite Wash, in terms of everything had a different name for the same thing. Anyway, question from Victor Agbe Davies. Question for Hugh Walker. In areas where you have a lot of channels coming through, how do you handle your method of geosteering?
You mean channels? So I think the question may be, what happens when, I think you might be asking what happens when the model doesn't fit the assumptions. Is that fair? Is that a fair?
I don't know, Victor, let me open your mic and let's see. So, yeah, that's for Hugh Winkler. Okay, so let me find you, Victor. I think I'm making you a panelist. You should be able to talk.
If I understand what what the question is, it's what you know, a fundamental assumption that we do frequently in geosteering is that the the structure varies laterally just by dipping and faulting. And if you have lateral facies changes, or I think where you're in, a channel intruding in, changing the thicknesses. And so you're violating the assumption. And we handle it the same way manual geosteering processes handle it. And that is, we insert a new type log. So,
so Victor, I've opened it. You should be able to speak if you'd like to, and you also open your camera if you want to, but if you don't, that's okay. I think I'm a talent at putting people on the spot.
yeah, I think I figure out, I think the question means what happens when you have laterally varying structure that doesn't merely change by dipping and faulting. And one interesting way they can violate that assumption is when their thicknesses change due to crossing through a channel. And a
Yeah,
manual,
I accommodate turbidites and
Yeah.
discontinuities and lobes and
right?
highly variable.
Typically what you do is so I kept the pictures I put up there pretty basic, but you can place if you have prior information that, first of all, if you don't know it's there to begin with and it's not part of your prior information, the system will accommodate to a large degree that by simply just adjusting the dip to look like your channel. But if the thicknesses have really changed dramatically, you need a new type log, and it falls in the category of noise in the model. And if you don't have a new type log, if you have a new type log, so you can place a type log, to represent the new stratigraphy, the new thicknesses you're seeing at the channel, and then yet another type log beyond it to the stratigraphy on the other side.
Great. Okay, so we have time for two quick ones. Mark Hamzat, would you like to ask your question with your voice, or would you want me to read your question?
Sure, I can ask with my voice. So thanks a lot, Dr. Nash. So David, in your one of your recent newsletters, you talked about the reason why energy technology investment is right. The current time is right now. And so you mentioned business cycles, the shift to manufacturing, the great crew change, changing energy needs, so ESG, the global energy mix changing, and then also the increased velocity in data. Could you expound on a couple of those points or summarize a couple of those points for us, please?
Sure. The business cycle is more of an investor component, that it is somewhat of it's a consumer staple. So even in a down economy, there's a need for energy consumption, and you don't see a lot of elasticity there. And energy tech in particular offers an opportunity to take advantage of growth with defensive position in terms of cyclicality. The shift to manufacturing, one of the things we say is that the E in E&P no longer stands for exploration. It stands for efficiencies and economies of scale. And when you look at industries that go through this type of a shift to a more manufacturing process, the technologies involved that enable that scale and that efficiency and that manufacturing tend to capture a disproportionate amount of subsequent business margin or profit margin. And that's just because this becomes a strategic advantage and like a red queen race where the entire industry is running as fast as it can to simply remain in place and has to run twice as fast to advance. And so the technologies that enable that race tend to capture a lot of the margin. In fact, Barclays came out with their now known report in January where they said they see $150 billion of value, I think, to the E&P space from digital technology and $30 billion of revenue to the energy tech companies that enable that. I think that ratio is wrong. I think it's 100 billion to the energy tech companies and 70 billion to the E&P companies, just because you'll be able to demand a bigger pound of flesh. If you don't adopt these technologies, you're out of business. Those that adopt the technologies will compound capital faster and be able to acquire assets at better prices. Then there is a great crew change that's well discussed in the industry. The crew change is that there's a demographic shift. We've also now had a COVID shift where barriers to adoption are changing. Ways of operating are changing, and new employees that are pulling for technology and data-driven decision versus pushing it away. And then there is a changing mix globally with ESG needs and greater demand for energy. We, over the modern hydrocarbon era of the, call it 150 years or 100 years, we've delivered excess energy to roughly 2 billion, some energy to 2 billion people, and inadequate energy to 2 to 4 billion people, and everybody else on the planet wants what we have. So energy to me is a growth industry, and we have ESG needs to environmental, social, and governance to and what that sums instead of just the three terms. We have needs that need to be met globally. If you want to raise people out of poverty, one of the best ways to do that, and one of the highest correlations to GDP growth, is energy consumption. And so if you want to deliver medicine or food or whatever it is, it's you need energy. It's the feedstock of the global economy. So I believe that energy technology companies can help meet those ESG mandates, or can help an industry operate more effectively and more efficiently, and as such, you're doing more with less, and you're producing more with less. So
really good answer. So Misung Yan has posted to the panelists a really cool link. I wonder, Misung, would you mind posting it to all the participants? That would be great.
Oh, yes. Yes, when I send it to, yeah. Is there any chance I can share the screen? I just put it up on the screen.
Let me elevate you here.
Yes.
Let's see.
Also, I want to put my comments regarding the data quality and the data analysis. So I think that when people think about the automation, first thing is we will be taking over, and no engineer, the robot, the AI will take over people's job. But after,
okay, I'm promoting you right now to. Okay. Sorry about that. This always happens when there's a lag. Misung, are you here? No. Oh, I was trying to get her to be able to.
I'm disabled. Could you enable me to?
Yes. No, I'm. It takes a 3-step process, and then there's a lag. Sorry about that.
That's okay.
Here we go. You should be able to now.
Okay. All right. Yes.
You can just share your screen.
Yeah.
Good.
I pretty much share the takeaways from the 2019 SPE Data Convention. And the interesting part is the organizer invited outside oil and gas companies like Uber and AlphaX. So basically my takeaway is people are looking for the breakthroughs in the oil and gas industry because of those issues and the challenges we have. However, due to the complexity of the subsurface data side and uncertainties, what I see is engineers, geologists need to get used to use the data tool or analytic tool to enhance their productivity. At the same time, those data tools cannot replace the human brain like engineers or geologists. So I pretty much agree what David said, is in the future, it's a combination of a computer plus a human being or domain expert. So that's my 2 cents.
Oh, that's great. That's really interesting. I really thank you for including that. And so I think everyone's familiar with Uber, but what is Alpha X?
It's also a data company. It's new to me. It's use data to do some analytic work. However, that's out of my domain knowledge. I'm more on reservoir engineering side.
Okay, that's good. Wow, this is like really wonderful. Well, we have time for one tiny little question, and I noticed that Munira Raji asked if there's a source for like a free source for mineral data, and I'm assuming that would be global. So if anyone has a suggestion or idea, please share it in the chat box, and that way we can always help each other. Well, so I just noticed the time, looks like we're out of time. And I just want to thank everyone again for so much interactivity and interesting conversations. I've recorded this, and so we're recording it now. So I'll process it and share the link with everyone. And I've put together a post or an article in LinkedIn where I have kind of one-stop shopping for all the future weeks. So you can go there and just click on the link and register. And once you register, even if you can't make it, it's fine, because it means that you'll have access to the recording. And my goal is eventually, once I have critical mass, to go through each one and sort of summarize, make all the recordings available on the web, and then also have links to useful articles so that they can be something of a repository of just really valuable information. And the goal, again, is to just think about how to pivot, how to be creative, how to respond in a really fluid time, and basically help ourselves help each other. Anyway, so thank you. So thank you, Larry and David and Chad and Hugh. And also thank you for all the people who attended, and also for Julia and Mark for promoting the event so well. And I hope to see you next week. So thank you.
Thank you, Susan.
Thank you.
Thanks.
Thank you.